Hi and welcome back to my third development log for Toast Engine. So before we get into the actual development log, I would like to say that I know that this video is long. I'm still trying to figure out the right how the devlog is going to be looking. Are they going to be 15-20 minutes devlog, or are they going to be 40 minutes to an hour long development logs? So let me know in the comments what you would like to see. I will become better over time to explain everything I do and to show them off with animations and whatnot. So yeah, let me know if you have any thoughts in the comments. In this video, I thought we would go through what I've done the past couple of months. And that includes a UI 9 patch system, Deffered Rendering, shadows, mesh, level of detail groups, dynamic image-based lighting, and screen space ambient occlusion. But first I would like to talk a bit about how I plan things and how I keep myself motivated throughout the process of developing Toast Engine. I have this Trello board and I have a number of lists here, so I call them versions. 0.1 I now have up until 0.5 planned. And I add things to the list. I try to add larger and medium and smaller things mixed together, so that if I feel like, okay, version 0.2 now have too many large things, let's put that in 0.3 instead. So right now I'm filling up 0.4 and 0.5. Each version or each list have like some kind of end goal, as I call it. Something that improves the engine front end. That's very important. I need to see improvements to keep myself motivated. And in version 0.1, that was dynamic image-based lighting to improve the lighting quality of the scene. And also have the next version of starships ready to be imported into the engine. And the idea was that that version of starship would have LOD groups, or level of detail groups, that would be used. So in between each version, I plan to create one of these videos. That's why I also would like to have something front end, because it's nice to show off things, right? I take the list and I start adding them into a physical list, which is basically a paper that I have on my desk. And I don't plan it out everything at once. I just kind of add things as I go on this list. And this also enables me to be able to cross over things more often, and that keeps me motivated. And it gives me like a feeling of progress, and that's, I think, is really important. And I'm never in a situation where I sit down in front of the computer and gonna do some work on Toast Engine and I need to think of what I should do. I have the list there, and as I go I add more and more. So for example, for version 0.1, that came out to be 3 pages of things I do and crossover, and some days I just cross over 1 and maybe not even 1, and some days I work on really well and I get to cross over 10 of them. But it helps me keep my motivation up. Enough of planning talk, and let's get into the more interesting stuff I've been doing during this release. And let's start with the 2D renderer and the 9 patch system that I've built. You can see here on the screen a benchmark from the version before, like the last video I did. And you can see the duration between begin scene and end scene for the 2D renderer is 2.7 milliseconds. So, and what I did was I had one draw call for each element, UI element or 2D element in the scene. And I also changed shader between, and I also updated a lot of the constant buffers that I used. So that was a lot of waste. So what I did was that I changed it to doing only one draw call. In the future I will have to divide it into more than one draw call, but for now I can use one draw call. It's a lot better. It's down to, as you can see, 0.233 milliseconds, so a major improvement. So let's get into the 9 patch system that I built. The 9 patch system is a way to rendering panels by using textures, and a way to make the texture scalable, basically. So if we take you see the texture on the screen here, that can be divided up to 9 patches. You have each of the corners, you have the edges, and you have the middle part, and they all scale in different direction depending on what you need. So you combine the two and you have the 9 patches like this. And then you use shader magic, basically. You do some shading code, to make it scale as you would like. And that means you can have a panel at any scale you want by still using this small texture here. And you can use the texture on several panels as well, instead of having individual texture for each panel size, basically. So how does that look in reality in my implementation then? Well, we can jump into Toaster and check at the game, and you can see directly here in the 2D I've changed the font. Actually, it's the previous font was really bad, but this is how the UI looked when we left it. You can see the color here, and it looks very plain and simple. What I've done is that I've created an information pop-up, as I call it, for my new starship, and we can look at that later in the video. And I've also added the visibility option here, so we can pop it up by clicking visible, and this is something you can set through the C# scripting language as well. And we have some information here about the starship. The red square here is for closing the window. The UI buttons can't be texture at the moment, so I'm gonna fix that in an upcoming update. But if you look here to the right, you can see that we now use a color, the albedo color here. We can disable that and we go and use the texture. Now it's white, but if we go and choose the texture that we talked about previously, we get this. So now you can see it has borders, it has an interesting blue, it actually has some grains to the blue middle part there, but it uses the texture and the 9 patch system. So if we go and scale this, we can now scale this to do anything. So we can have it at any size, but it still uses the same texture. So that makes it, we can use the same for the timer UI we have over here. And now, yeah, here you can see the issue with having just one material for every UI element. But we go like that, and all of a sudden it looks a lot more interesting, the UI. And this is not the final iteration in any way, so I'm gonna get back to it. But this is a big improvements from the last version. I'm happy with the current state of it. So as I was editing this video, I forgot to show you something about the UI. That if you hit play here now, you can go up and you see the ship starts falling, of course, but you can click the starship and you can actually get some information of what's happening here, the altitude, and yeah, that's pretty neat. You can close it and so, yeah, just wanted to show you that. So let's start talking about Deffered Rendering and why I choose to implement it in this release. I've had some issues for a while now that my renderer was built basically home built. I had my own way of handling things, and every time I wanted to add some new features to it, like screen space, ambient occlusion that I did in this release, I had to basically adapt it to my renderer, and it was hard to follow guides, and I didn't really use any industry standards that other people use. So I decided that now was a good time to implement something called Deffered Renderer, which is a industry standard, and it's a lot of the guides uses it. So when you want to implement something like screen space ambient occlusion, it's a lot easier because basically you have a deferred renderer as well, which have the same principle as other deferred renderers. So what is a deferred renderer then? Basically you have two main passes. You have the geometry pass, or the commonly called G pass, and then you have the lightning pass, and then in between you can do different passes as well, which we will talk a bit about more later. But the G pass, it has usually 4 render targets. I have 5 in my engine. We have the view position, or the position. This can be view or world. I use view for increased precision for me, so basically it's from the camera's viewpoint. So I do a render pass and I output the view position. I do the normals also in view position, and I do albedo and metallic together as one. So the alpha channel is basically the metallic here, and then I do the roughness map, and here I only use one channel, so I only use the red channel. You can see that's why the image is so red. but here I have options for more functionality in the future where I have 3 more channels to use. And then I do my 5th render pass, which is my ID pass, which I use for clicking and so that I can see what entity is being clicked on basically. And then it's moved on to the lightning pass, where all of these textures are combined into one final product. And then when the lightning pass is done, I do additional passes for atmospheric scattering, tone mapping, and the skybox, for example, and that produces the final image. So you can basically see here I had to throw the 3D renderer out and start over again, and then I started implementing everything back in again, and you can see here is the planet back. So here I actually have the G pass or geometry pass and the lightning pass back together, but I don't have any post-process passes, so it looks a bit dull, right? I continue with implementing the skybox pass again, and then I went on to implement the atmospheric pass, and here you can see it's starting to look like it used to do. When I were done with the deferred rendering, I went to fix one of the smaller issues I had. I thought, now I've done the deferred rendering, a pretty big one, so now I want to do something small. Turns out the issue wasn't that easy to fix, it wasn't a small fix, and in the end I fixed it by adding shadows. And we can, if we go into the engine here, we can check. And now, yeah, while we're at it, I've added smooth shading. So you can do this if you like. Now, I think this looks a lot better. So for now, we're gonna continue with planet looking like this. Okay, so the issue. We have the sunlight and it rises above the horizon, but when it goes below the horizon, let's put it to, I think this one is 70, you can see here, it's lit up the bottom part of the starships, which is really annoying because it shouldn't, right? And the easy fix for me would be that I just like to turn off the light when it's below the horizon for an object. Don't add directional light to it, and that should work, but I never got it working correctly. It looked really weird. I got some bugs, so I was like, okay, how would you solve this the correct way? And the answer to that is shadows. So we add shadows. Click the button here, and bam, works like a charm, right? And now we can move the sun back up to see it, boom, like that, close to it. And you can also see shadows on the ground. But it's a very basic shadow implementation. There is no cascade shadow maps. I have that in, I think, 0.3 or something, that I'm gonna work on shadows again and improve it, because we also get some artifacts on the objects themselves. If we turn off shadows again, you can see how it looks, and then turn on shadows and you see some self-shadowing. And from what I understand, this can be solved by using cascade shadow maps. So that's gonna happen in the future, but for now it solves the issue. It's also nice to have shadows here on the ground, and I think actually if we move this object down a bit, this is again one of the issues with dragging, is really annoying. But you can see it's not 100% correct there. I think actually it's pretty good, but there is some issues. Tilt it a bit, you can see it starts getting bigger. But one of the major issues when the sun goes down. Let's follow the shadow. I think at some point it should get like hollow. No, it doesn't. Yeah, there's some artifacts to fix. And another thing I can show is now how I light frustum. So basically, I'm not doing shadows on everything, I'm just doing shadows within this frustum. Because at the larger scale, there's no need, like you can't see the shadows anyway. It doesn't need to have the details that I need close up to the camera. You can see the camera here. But in the future, this might be tweaked a bit more as well to be able to handle the shadows a lot better. But for now, this works. It's a good first. It's good enough, as I call it. and I will get back to it eventually and iterate over the function again and make it even better. So I'm really happy with what I have right now in terms of shadow, but I will improve on it later. Awesome. On to the next thing. One of the biggest time consumer for this release were the the Blender and rebuilding a new starship, what I call SN3, serial number 3. I'm not that used to Blender, I'm still learning it. So for me, it takes a lot of time to do different things in Blender, but I'm increasing my knowledge in Blender, and I'm getting better and better, but it takes time. And since I'm working out all the basic functionality, I'm not that much in Blender at the moment. So I basically am just there when I do this these starships. But for this release, I wanted to create the next level. You can see SN2 over here to the right, and then the new SN3 here. And one of the things you can see, we have the raceways here, we have antennas. What you don't see is a payload, but yeah. Another thing, let's see if we can. Yeah, you have to be really close here due to how the shadow and lighting works, but you can actually see the heat shield. So I had the opportunity here to learn a new software called Substance 3D Designer, and Adobe that is generally used by the industry. So I took the opportunity to learn that after asking around, like how would I recreate the heat shield map basically. So I hope in the future that will be more easier to see it, but I think the shadow destroys a lot right now, but I think it's good enough for now. You can see it that it actually heat shield ties, so that's nice. You can also see that it actually has a small, I don't know if you can see that small edge here, actually is the heat shield. One of the things you see when I'm moving around here is that I have some issues with it, some bugs, and it's also in game when I press play, the same thing happens. But I intend to solve that in next release, so that's one of the things I really need to solve now. So that's coming up soon. Another thing I did, and that's gonna be kind of hard to see, but if you focus down here to the right, you can see the vertex count currently being rendered in the scene. And I've added mesh LOD groups. So I wanted, like SN2, it was always the same number of vertices, and it was a lot of them. So normally you have different level of details, like you don't need to have the raceway and the antennas if the starship is far away in the horizon. So that's something I wanted to add in this, one of the big features I wanted to add. So I watched some videos and I named them. So like when in Blender, when you work, you have different models. So you create like a high poly module, and then you start topology, something it's called, when you basically remove vertices while trying to keep up. I have, like, normally you would bake, it's called, when you bake normal maps onto a lower level of details model, so that basically you use the normal map from the high poly version on the low poly version. So basically you can get details like you would if you had a 50k vertices, but on 1000k vertices. That's not possible in the scale I'm working on. That's more for like objects in a room, for example. But when you're working with something that is starship, which is 50 meters tall, that's hard to do because the texel density, the density details, is you need like 32k or something, and I am working with 4k. So that's an issue I had to work around and wait with. But for me now, the most important part was to get different level of details when loading a mesh into the engine. So in Blender now you can name something like LOD0, LOD1 at the end, like underscore LOD0, underscore LOD1. And then the engine will notice that, and instead it will load this as a mesh with LOD groups and put it in a vector, and then use the vector depending on like because you have you can see here I've added some HMI stuff for the editor. In Toaster you have, like, you can set the threshold when you jump over different LOD when you move to the next one. So I know that Unity uses, like, it calculates the percentage the object takes up in 2D space. basically in screen space. I don't do that, I just have a distance threshold, but it's kind of the same. In the future I can add a bit better, but for now I just wanted to make sure that when a starship moves away from a certain threshold, the number of vertices will go down that the engine uses. So you can see here, for example, if we put this down, we're low, green one is the highest level, and watch the number of vertex count here. We can see if we can get it there. You see the jump? You can actually see some details changing. I mean, it's not perfect. I'm learning Blender, as I've said, but it do actually change mesh. It uses a different mesh width, so it basically takes away like 35,000 vertices lower. Still raceway and the antennas are visible. They have a little bit less of a detail. And when you go down to the red one here, see if we can show that if we change the values here a bit. So now it's on the yellow area, and then we push this really low, and then I think we actually have to push the starship away a bit. So it's basically away from the camera we're talking about here. So if we set it to 500, does that change? Yeah, now we're down even further. Now you can't even see the raceways and the antennas. They are removed basically. So now we're down to 32 vertices, so additional 15k removed. As I've said, this can be done a lot better. I need to learn more about Blender, but I have the functionality there now to use. So I'm really happy with this, especially how the toaster HMI stuff turned out to be. So yeah, and then when I add more objects in the future, I'm gonna keep using these functions. So yeah, it's gonna be super exciting. Okay, on to one of the things I really wanted fixed in this release, and that was dynamic image based lighting. So basically EBL, as it's called for short, is a way to mimic ambient lighting in the surroundings depending on your... It's an approximation of the ambient lighting basically, and you use a texture cube, which is your environment basically. And if we turn off the atmosphere here, and the stars are now gone, but you can see, let's also turn off the shadows here. It used a very black, the star map I have, a very black, very dark texture cube, and that reflected onto the objects in the scene, so they looked a lot darker than they actually should have. And that was fine. Most engines, they have like some kind of environmental map. My environmental map were the star map, so it was really dark. I could have dragged up the exposure of it, but then like the intensity of it, but then the stars would look weird instead. I added atmosphere after that, but the EBL was done once at the scene load. When the scene were loaded, the environmental map were built from the star map, so that's still used. Even though it was bright day, it was still really dark. So what I needed was a dynamic image-based lighting, a dynamic IBL, which updated depending on the position of the sun. And right now we have the sun up here, and you can see I also made the sun a lot smaller to actually make it more realistic. But it's still dark, right? So I needed to calculate the EBL texture cubes, recalculate them basically. And I do that, so what I ended up doing was that I update one face of the cube. The cube have 6 faces, right? So I update one face every frame, so it takes 6 frames to update it as a whole, and that's okay. I don't need them every frame, due to the fact that the sun actually moves that slow. I mean, the difference in the EBL lighting is not a lot between 100 or 195 degrees, right? So yeah. So if we can activate dynamic EBL now, IBL here, bam, and you can see you get a lot of light. You can see it very clearly on the fins, on the flaps, forward and rear flaps. Boom. One of the issues I have is like when you tilt the camera down, it kind of like pops a bit, the color. I think that's, I think it's because the color between the atmosphere and the planet is at such a difference. There might be also be some code errors, but for now it's good enough as always. But now, like if the sun is at 5 degrees angle, the EVL light will reflect that and will be updated as the sun moves. So that's really, I think it's not perfect, but it's an improvement for sure for the looks of the objects in the scene. But for sure you can see here, for example, it's a lot darker on the side than it maybe should be. So yeah, there's some things to look into here, but it looks a lot better than it used to do. You can add shadows as well, and then you have this issue again, the self-shadowing that I'm gonna fix. Yeah, that's all for dynamic image-based lighting. The last thing I developed for this release were screen space ambient occlusion, which is a way to calculate ambient occlusion in screen space, hence the name. It was developed by Crytek in 2007 to be used in their game Crysis, and it's been broadly used ever since in the gaming industry. So I had it on my list. I really wanted to try it out. Turns out when you have an open terrain scene like I do, it doesn't really do as much as it would in a closed environment scene. But if we check over here at SN2, it's best shown here. You can see the bottom is pretty lightened up right now. Let's turn off the shadow because it looks shit. And then we turn on SSAO. And you can see here that it gets a bit dark. You can see the flaps. You even see here on SN3. You can see the colors being a little bit, hopefully gets a bit more depth to the scene. As usual, this is not perfect. It's the first try. I'll get back to it and work on it in later releases, but it's in now. I have a render pass that does it. Yeah, so that's everything that I developed for this release. Let's talk a bit about what I'm gonna do in the next one. So what is next up with Toast Engine and in version 0.2 as I call it? Well, the first thing I'm gonna fix, and it's these two first ones here, is the movement. And if we go into the engine, you can see this works okay in editor mode. It's tricky somewhere, and I know you have this issue in Blender as well, that if you move too close to something, basically the controls flips out a bit. I would like to have it dynamically so that when an object is targeted, you have that as the focal point, so to say. So when you zoom out and move, you move around that as the centerpiece. And then if you have nothing, if you have nothing connected, nothing targeted, then you basically have the origo as a focal point. But the bigger issue is when you hit play here and go into the actual engine. When I zoom out, you can see it doesn't really work. Movement doesn't work. The objects aren't moved because, you know, as we have floating point origo. So like when the player moves around, the camera isn't moving. Everything else around it is moving, and that is to increase the precision of the calculations closer to the camera. But that makes I have to do some additional stuff when actually moving. So that used to work, but after I rebuilt the planet system in, I think it was the second devlog or first devlog it was, because I did the physics systems, I didn't get re-implement the movement. So I'm gonna do that. And then we have a particle system. So basically the idea here is that I'm gonna create a particle system that is towards, so like the first version of the particle system is gonna be able to create rocket exhaust. So the idea is that I would like to have rocket exhaust coming out of the starship when it gets closer to the ground and prepare for landing. So that's something they're gonna fix. That's gonna be awesome to finally get done, and I think it's gonna do a lot for it's gonna look a lot more live. And then in version 0.3 I'm gonna add a landing button, and then I'm gonna combine the animation stuff I have with the particle system, and then have it basically land on the surface. Yeah, and then I have a small one. Camera far should be lower at lower altitude to improve performance. So like right now the camera far is static. It's always set to something, but it should be dynamic because the frustum can be smaller at lower altitudes, but it needs to be larger at higher altitudes, so that since you see longer or more of the planet, so you see further into the distance at the higher altitude. So I'm gonna fix that. And then I'm gonna add a custom ImGUI menu bar. And that just looks, if we go into the engine, we can see here, if you look in the engine, you can see that white bar over here is gonna be removed, and it's gonna have a more real application menu bar. It's gonna be nice to get done. Also, something I'm gonna fix is the infinite drag for drag float examples. So one of the most annoying things in the editor is when you try to move, if you try to move SN2 here, for example, it goes, if you want to go down, it's pretty, it goes okay because you have a lot of space. But if you want to move this up, the mouse cursor reaches the end of the screen of the monitor and you can't go any further. So it's really annoying. So I'm gonna fix that in this 0.2 release. I'm also gonna look into the delta. Like, this is way too much. Like, it should be a lot easier to move things around. So that's something I'm gonna take off my list and get done in this release. I'm also doing fixed time steps for the physics engine. I tried to do it when I did the physics, but I didn't really get it working. And that's the physics engine can get a bit unstable if you have different time step every time depending on your delta. But if you have a fixed time steps, then that's it a lot easier to make it stable. So yeah, I'm gonna fix a pretty small thing, I believe. And then we have project settings. So basically when you load the scene, these settings over here are basically forgotten. So every time you go in, for example, you have to deactivate. You don't want to see the grid maybe, or the camera frustum. So you need to deactivate them every time, and I'm gonna save them in the scene so that you actually have that. When you open up the project file, you get the settings as well. It's a precursor to having the project basically being a project, because right now it's just a scene in the editor, but it's going to be a project in the future. So that's why I'm doing that. Prefabs. So basically, if you would like to add a starship while in game, you would like to add prefab starship that have all these components already included. Otherwise, you need to add an entity, and then you need to add the transform, the mesh, the rigged body, and the box collider, and all of that. It takes a lot of time, and it's easier if you have a prefab that you can preload. So it's basically an asset. Then it's going to be easier to add starships in game, and one of the reasons I do this is in one of the upcoming releases, not 0.2. Then I'm going to have a UI where you can add starships basically to your game. So that's going to be really interesting to see how that works out. Yeah. And then we have icon for engine, top right corner. So for example, if you go down here to the menu bar, it's going to be an icon. So same up here to the left. So pretty easy fix, but interesting to finally get that done. Edit name of entities by double clicking. So this is something I wanted to implement for quite a while. I want to, right now, if you want to change your name here for Starship 3, you have to go in here and you can write Starship 4, for example. It changes in the hierarchy, scene hierarchy here. But I want to do it directly. I want to be able to double click this here and change it inside of the scene hierarchy. It's a small fix, but something I really wanted done. I'm not sure why I want it done that badly, but yeah. So I'm gonna fix that as well. It's gonna be super fun. Clamp text in editor. That is issues I'm having here, because you can easily see it on the rigged body that you have. I need to fix this so you can actually see what it says here, and the more I add, the more issues I get with this. So I'm gonna fix this up. Make it a bit nicer and easier to read. And then yeah, I have an icon on taskbar as well. And then planet not clickable. So basically I don't want the planet Mars to be clickable. It takes up, you can see it happens now, but it's just, I don't know. I don't think planet should be clickable. It's going to be a singleton or an entity, and then it's going to be, the planet is not going to be part of the entity component system in the future. It's going to be moved to its own, so it's not going to be here. You're going to have like this own pop-up with all, because you have so much settings for the planet, right? So, oh, this is interesting. So what I'm going to do is I'm going to have, you're going to get it your own pop-up basically, because the whole engine is surrounded, like it's going to have one planet. It's not about building a solar system, it's about building like a world on the planet. So the planet is going to be one thing only. Yeah, so that's what I'm planning for 0.2. If you watched this far, good job. And this video became a lot longer than I first anticipated. So yeah, thanks for watching, and I'll see you soon. Bye.